Hello, hello, welcome. Can everybody hear me? Yes? Great. So I could be a little loud, so just letting you know you do have a volume that you can manage in your right-hand side, I believe, of your headset, okay? So good morning, and thank you for being here. Really happy to have you. Let me see if I can see you. How many security professionals do we have in the house today? Okay, we have a few. And I have a question for you. Have you ever worried that your developers will make a configuration mistake and publish company data out in the... Yeah, well, I worry about that too. I'm happy. So that's great because you're in the right place. Today, we're going to talk about how you can mitigate that risk. We're going to talk about how to establish a data perimeter in AWS. And we're really lucky today because we have Cap 1 who is going to share with us how they actually did it in their environment. My name is Laura Rice. I am a solutions architect in the Identity Solutions team. And I'm here today with Lauren and Chris from the IAM and authorization team in Capital One. We're going to start this session by discussing the concept. What is data perimeters? What are the tools that you have in AWS? And what are the risks that data perimeters can help you mitigate? After that, I'm going to pass it on to Chris and Lauren so that they can show you how they leverage data perimeters to accelerate service adoption in their environment. So let's get started with the concept itself. So what is a perimeter? Maybe a few years back for you, it meant that you had total control of your physical environment. You relied on network appliances like firewall, DLPs, proxies that separated your service with non-public data from everything outside in the internet. For the most part, everything had an IP address, a DNS record, and you were able to look at that IP and assert whether the communication should be allowed or not. Now, things started to change a little with time, and companies started to host products and selling them to you. And at that point, you needed to make sure that your employees could access those products over the internet. You were allowing them to access those products over public endpoints. Endpoints that were shared with all other customers and that are not part of your perimeter. Now, here is where things change for you. Because now you had your traditional perimeter to maintain, and you also had a perimeter around this software. And this model continued to evolve throughout the years. At some point, you could also create your own products and sell it to other people. You were able to integrate with other companies and do collaboration. Maybe you also were able to access data from another vendor and create insights out of that data. And that was very, very powerful. But as you were doing this, you're slowly poking holes in your perimeter. And now, you need to keep up with your organizational evolution. You have all of these resources, you have softwares and resources around your whole organization. And most likely, as a security professional, you're not managing every permission for every resource in the company. You have delegated this out. Now, as your organization grows, you now have also a growing member of your security team. And you end up with a small army of professionals trying to keep up with organizational changes. In AWS, though, we have data perimeters to help you manage this at scale. And data perimeters is a set of coarse-grained controls that allows you to assert that only trusted identities can access trusted resources from expected networks. Now, what trusted and expected means depends on your company, on the characteristics and the business needs that you have. But the idea is that everything on the left-hand side, in the green box, your left-hand side, everything on the left-hand side is yours. It's your on-prem data center, your cloud applications, your AWS resources, everything that belongs to you. And everything outside of that out in the internet, we don't want it to communicate with our environment. We wanted to create a clear line between them so that it allowed us to identify access patterns that you might want to avoid. For example, exfiltration of data, infiltration of data in your environment, misuse of credentials. These are some of the access patterns that data perimeter can help you identify. And once you have that clear, your centralized team can codify those access patterns in policies that will help them meet compliance requirements at scale, create controls to ensure security invariance in the whole organization, and that helps you mitigate the risk of misconfigurations that can lead to unintended data exposure. So data perimeters, customers have told us actually that data perimeters enables their security team to feel more confident about hosting sensitive data in the cloud, about enabling their developers to test and to adopt new technology, which in turns allow them to innovate faster, right? So data perimeters can be an always-on boundary that will help your security team find a balance between your security goals and your business goals without compromising agility. But how do you actually implement this in the environment? You need to have a clear understanding of what trusted and expected means for your organization. Generally, trusted identities are those principles that belong to your accounts, that are part of your AWS organizations. Trusted resources are resources where you store data, like your databases, your S3 buckets. And expected networks are, your IP space, your corporate IP space, your VPCs, right? However, there are also situations where AWS resources, AWS services access resources on your behalf. For example, I think all of you will be familiar with this, but CloudTrail. When you use CloudTrail to send logs to your S3 bucket, CloudTrail uses a service identity called service principal. The name is cloudtrail.amazonaws.com. So CloudTrail uses that identity to actually send those logs to your bucket. When that happens, that call to your bucket is actually coming from the CloudTrail network. So if you're using some of these products, these are access patterns that you also need to take into account when you're defining your zone of trust. With a clear understanding of who, what, and where, then you can start designing controls, policy, authorization policies that you're going to apply to your environment. Now, before you actually apply those to your environment, you need to see what access patterns you're trying to avoid. And I want to talk about some of them. The first access patterns that I want to talk about, the first risk and consideration for the data perimeter control that I want to talk about is unintended access to resources through corporate network. And this, I will give you two examples on how this can happen. But let's say that you have an application that is using Lambda to write employee information into an Amazon DynamoDB table. Now, unfortunately, one of the developers that was working on that application was terminated. He is not happy. So he decided to intentionally take some data with him. So what is he doing? He could do a few things. One of them is if he has a personal AWS account, he can bring in his personal credentials, he can embed them into the Lambda code, and then he can try to exfiltrate data. When personal credentials are introduced into your environment, the VPC endpoint, the policy in the VPC endpoint becomes your primary control to make sure that only identities that belong to your environment can use that network. What else could happen? Well, if this developer still has access to the account, maybe there wasn't a procedure to remove his access in the first place, right? So he was terminated. He still has access to his corporate credentials. He can use his corporate credentials. We have a control in the VPC endpoint policy saying only my principals can use this endpoint, but corporate credentials are your principals. So he can use his corporate credentials to try to exfiltrate data. Or, better yet, if there aren't any other compensating controls and the service role for Lambda is not restricted, let's say developer had a hard issue creating this role at some point, so he said this Lambda can write to any DynamoDB table. So now he can just use that service role to actually try to access a DynamoDB in his account. So he will first modify the resource-based policy on his account, allow cross-account access, allow requests coming from your corporate credentials, and easily move data. In this case, we can add another control to the VPC endpoint policy. And we can say that even though those are principles that we trust, those principles can only access trusted resources as well. So that network is only usable if the principal belongs to my organization and the principal is trying to access a resource that belongs to my organization. Now, this works if your requests are being routed through your VPC. But there are valid situations where requests are not routed through your VPC. For example, maybe you already had Lambdas in your environment that were not deployed on a VPC. In this case, this rogue developer could use the corporate credentials to try to exfiltrate data. There is one other example that I would like to share, which is when you're using services that offer some sort of service-to-service integration. And this is because that kind of offering, by nature, that request is not routed through your VPC. And what am I talking about? Actually, think about S3 replication. The developer could set up S3 replication with a target in an S3 bucket outside of your environment. So in this case, by design, because of the fully managed nature of the service, then the requests are not passing through your VPC endpoint. So you want to ensure that even though the requests are not passing through your VPC, your corporate credentials can only be used to access your resources. You can use a service control policy to do this with the resource org ID condition key. When you do that, all of your principals can only initiate requests if they are accessing, all of your principals can only access resources that belong to your organization. Another probably very well-known consideration is credentials used outside of your corporate network. And this can happen in a few ways. I got to say that most of you are familiar, but it doesn't have to be this angry developer at this point. It can be any of your employees. Maybe the developer was working really hard, got tired, took his laptop, and decided to access company data from an unexpected network. So it doesn't have to be intentional. But accessing sensitive data outside of your network could lead to potentially this developer is bypassing all of your security controls. And that could lead to unintentional data exposure in a public space. And that, I would say, is something that we could still deal with, but it really depends on the risk-based assessments that you did on your environment and the risk tolerance that you have. Another way is if your credentials are actually being used outside of your corporate network, maybe it's not one of your employees. Maybe it's somebody who got a hold of those credentials and is now trying to access your resources. I think a very common situation where this can happen is when developers accidentally push code and it contains the credentials, right? But that's not the only way that credential theft could happen. It could also happen through social engineering. Some customers have tooling where they automate the process of authentication and authorization, where the user has to confirm or approve the request before the credentials are actually generated. An external attacker can take that request approval process, send it to a corporate user, capture the credentials, and then try to access your resources. But not to worry, with the network perimeter, you can help address this. With the network perimeter, you can use source IP and source VPC condition keys to say that even if those credentials were leaked, even if anybody has those credentials, they are not going to be able to use them outside of your network. And there is one more thing I wanted to mention today, and I think is very interesting. When you have services like AWS Lambda, AWS Glue Jobs, SageMaker that have different deployment types. Lambda, you're probably familiar that you can deploy it outside of your VPC. If you do that and you do have network controls in your resources and your identities, you have source VPC controls, then that Lambda will not be able to actually communicate with any of your resources inside that VPC. So the developer might be trying to use the Lambda code, but is getting access denied, though he doesn't know what is happening. He's not able to access any of the resources, and we will be messaging you. But what you can do is you can enforce the deployment of Lambda in a VPC with a policy, so that the deployment itself will fail if it is outside of the VPC. Now, this will, in time, train or teach developers that VPC deployment is a requirement in your company. And hopefully, that with time will make it a better experience for them, because they now know that they have to deploy the services on a VPC. Now, we talked about the risks. And this is the first step that you have to go through when you're implementing data perimeter. You do a risk-based assessment, you're examining your security objectives. You then decide what is trusted, what are my trusted identities, do I have any partners that I want to allow access to any of my resources. You define that in your environment. You trusted resources and your expected networks. And you can use that to design your controls, codify those, and authorization policies that is going to be applied to your environment. Before you apply those controls to your environment, there is a very, very important step. which is assess potential impact. You need to see those policies and see what are those policies going to impact when you apply them to your environment. Are your workloads, your current workloads, going to continue to work? Also, when you do this assessment, you might pick up access patterns that you missed initially during the initial design of controls. When the assessment is done, then you can start implementing data perimeter controls. You can add those controls to your automated process, right, to your operations. And as your company evolves, you always need to continue to monitor those controls to make sure that they still align with your requirements. Now, this is a journey. And as your company continues to grow and advance, maybe more workloads, more developers, more security professionals, you might want to make small adjustments so that the data perimeter controls are still aligned to your security objectives. Now, there are controls that you can use. These are the controls that you can use in AWS to establish a data perimeter. And this table right here is as a guidance for you. You do not need to implement all of this. Remember, you had to first do a risk-based assessment, and according to that, you can choose which one to implement. For example, the identity perimeter. This perimeter, I like to think about it as is trying to answer the question, who is making this request? And you can use this, the global condition keys, principal org ID, or principal is AWS service to address that. And principal is AWS service will help you with, for example, we talked about CloudTrail before, right? And we said that CloudTrail uses its own identity, his service principal, to access resources. So principal is AWS service will help you address that access pattern. Then we have the resource perimeter. The resource perimeter will help you answer the question, what is he trying to access? And you can use the resource org ID to help ensure that the principals can only access resources in your organization. And finally, we have the network perimeter. And the network perimeter will help answer the question, where is that request coming from? And you can use source IP, source VPC, source VPCE. There are a few condition keys here, but I want to call out one in particular, which is via AWS service. This condition key will help you address access patterns where services act on your behalf and sign the request with the user's identity. So something that you might be familiar with, S3 buckets, uploading objects to an S3 bucket that has KMS default encryption enabled. When you upload an object, S3 will make subsequent calls to KMS to create the data key that will be used to encrypt that object. That subsequent call is signed with the user's identity. So you can account for that access pattern with via AWS service. Now remember, you only need to use what is relevant to your organization. And I'm really happy to say that Chris is actually going to show us right now how Cap 1 actually did this assessment, what were the challenges, and how they implemented in their environment.
Thanks, Laura. Hi, my name is Chris Schultz. I'm a Senior Director at Capital One in our IAM authorization team. I've been with Capital One for 13 years, and the last 9 of which I've been working on AWS and Cloud IAM. Laura did a great job explaining data perimeter strategy, including what is available from an identity, resource, and network perspective. Now I want to kind of walk you through our journey and a use case we are using the data perimeter concepts to support our strategy and our goals. So the agenda for this part, I'm going to talk a little history, what we do today, and where we're going. But a little bit about Capital One. We are a Fortune 100 founder-led company. We're now a top 10 U.S. bank with over 100 million customers. We have more than 50,000 associates, 12,000 of which are actually in technology roles, and another 5,000 are in what we call risk management. And our founding principle, going way back in 1994, is that data and technology can lead the way and allow even large companies to innovate and be nimble. So let's look back at the past decade. We've done a lot. Open source first. We've modernized our data ecosystem, like many of you probably have. And now we're even releasing our own software products that we developed internally out into the marketplace to help others scale. But the most important thing we've done in the last decade is we've been all in on the cloud. And as of 4 years ago, we're 100% in the cloud, and we don't own a single data center. All of this has led to having a technology-hungry associate population that wants access to the latest, greatest things all the time, because those developers, those software engineers, always want to move faster and move into the future at a breakneck speed. But we're still a bank, and we always need to protect our customers' data and their financial lives. So let's zero in a little bit on our AWS journey. Oh, so many years ago, we started out with a handful of single accounts, and we've grown from there. Today, we have thousands of accounts. We're now actually one of the largest consumers of AWS. We have more than 2,000 applications running in the cloud, and more being built all the time. We have more than 85,000 EC2 instances and hundreds of thousands of Lambda functions. Now, I know there are other companies out there that probably have more than we do. It's not about being the biggest, but we're also a regulated entity, which makes this even more challenging. So we're still a bank. We have a strong risk management heritage, and we have regulatory complexity that comes with being a bank. And this really forces us to evaluate every Amazon service before we allow it into our developers to use it. So we have developers on one side that want the freedom to innovate fast, and we want to empower them. But then you have central teams like ours that really want to make sure your cloud resources are configured securely. And what we've realized in the last few years is the only way to do this is to understand the security challenges of a particular service is to throw a small army of very smart, detail-oriented people at it. And this is now a major part of our cloud governance process. So we have this small army focused on evaluating a service, figuring out the ins and outs of it, and ensuring that resources can be configured. Hand that over to the developer after months and months of work. They start using it and realizing it doesn't quite fit their needs. It's kind of frustrating as a security team, but that's an absolutely okay outcome. So we're looking for a way to kind of scale our governance process to meet the needs of our developers and not drive our security engineers crazy. So I'm going to talk about one aspect of the data perimeter that Laura covered, and that is how do you protect your credentials that are vended and ensure they're used within our perimeter. So this example is a couple of SCPs that we developed starting a few years ago. And when we started this, we only had a few hundred accounts and a few hundred apps in production. And we had some bad habits. We had developers that were overusing their roles across multiple services. You know, SCPs can be kind of dangerous. They're an easy way to kind of pretty much shut everything down. So as we approached this, we decided to target specific services. EC2 and Lambda vend tokens, and we want to prevent those tokens from being stolen. So let's look at this from the bottom up. That first green box there on the left, we're using a condition key called source instance ARN. So when you attach a role to an EC2 instance, that gets filled with the ARN of your instance. So we detect that with what's called a null condition check. So the way you read this is if source instance ARN is not null, it has something, then this SCP will actually control that particular use case of that role. And so we did that again to limit our blast radius so that we were only focusing on roles used in this context. Of course, the other thing you have to do is tell it where that credential can be used from. So as we move up this, you see the blue text, we're listing out source IPs. Those are typically the IP addresses of your external proxies, because remember, this is a public cloud, and you're making connections to public APIs that are outside of your network. But those connections can now also flow through a VPC. And so you also have to list your VPCs in the policy as well. So that's where we stopped when our first test. We had our source IPs, our VPCs, and our instance R, and we're like, yay, let's turn this on. We did it. It broke a lot. Things were failing left and right. This is when you learn one of these undocumented features about AWS, that every service team is very independent, and they have a lot of choices they can make. And how they access their control plane with your principles, with your IAM principles, they have choices. Sometimes they'll use your session and come from your network, and the SCP works beautifully. Other times, they're coming from their control plane, connecting on your behalf, and it's coming from an Amazon-owned IP or VPC. And that really messes with the data perimeter concept. So luckily, we had a lot of teams using EC2 and using Lambda. So we turned this on. We were getting immediate feedback with what's failing, looking in CloudTrail, seeing the access denied errors. And we came up with a short list of things that we had to bypass, that we had to basically exempt from this SCP. And you can see the list up there in the top. A little bit frustrating, but not too bad. You know, EC2 and Lambda are established services, and it was kind of tedious, but we got it to work. And at that point, the tokens vended, say via the EC2 IMDS service, could not be used from outside our network. So the other hard part about this is maintaining that list of VPCs. At the point when we did this, we only had a few hundred accounts. I think maybe around 300. There's a 1,000 SCP limit in the orgs at this time. So we just chose to attach these SCPs to individual accounts and list out those accounts' VPCs. There's some scalability problems there. You get above 1,000 accounts, this whole model breaks. And today we're sitting above 3,000. The other thing is we build VPCs and delete them all the time. So now you have to go into something that's already kind of high voltage in SCP and figure out where is a VPC, where do I add it, where do I delete it. Not very fun. We've automated all that. It's much more controlled now, but there are a lot of challenges in getting this to scale and getting it to work right. So again, EC2 on the left, and you can see the Lambda, very similar SCP, different set of API actions. A little oddity we found there too. What you have to exempt in from Lambda is different than what you do from EC2, and there's a different condition key. But overall, the pattern's the same. And then came Glue. EC2 and Lambda, awesome teams to work with. They know their stuff. They're great. We had tons of developers using it. Our own developers knew how it worked. It was great troubleshooting. Glue had not gone through our cloud governance process yet. So as we're expanding our data perimeter concept, this is what we were thinking we were going to normally face. Brand new service, let's evaluate it, throw the small army at it, and see what we can do. But that lack of CloudTrail data, that lack of usage, made this a lot harder to figure out. Glue also didn't have that IAM condition key that's up there in green. We had to ask for that. So we had no way of being able to limit that blast radius and say only invoke this SCP when that condition key was there. So we had to work with them. We showed them our EC2 policy and said, this is what we want to do for Glue. They went away and went, okay. They came back and okay, here's some IAM identity policy you need to attach to every role that your Glue users are using with our service. And we looked at them and do you know how many developers we have? Do you know how many roles we have? A coarse-grained control should not be in an identity policy on the roles. So we went back and forth with them. They finally got us the condition key we wanted. And then we realized the developers actually, when they create the resources, have to actually call an API a certain way to ensure that Glue is attached to a VPC. Lambda has a separate way of creating an SCP to force a Lambda to attach to VPC. Glue chose a different way. All of these nuances. It was kind of maddening. But we got there. It took a while. It took almost 2 years. But we do have a working data perimeter now for Glue. And again, different set of API actions, condition key to let us know, hey, this is being used for Glue. But this was not fun. And we're staring at Amazon like continually building new services, this taking the small army to actually evaluate it, developers super hungry to do this, business executives going, you know how much money Glue could save us, and we're here trying to keep it secure. So I think you get the point already. Scaling this in a regulated environment is hard. So now we're dealing with multiple SCPs for doing the same intent, which is protect your tokens, keep them from being used from outside your network. So the number of services is growing the number of SCPs. The number of accounts is growing the number of SCPs. You know, that's getting kind of hard to manage. We're actually really lucky because I mentioned earlier we had a limit of 1,000 SCPs. Well, just a couple weeks ago, they finally increased that to 2,000. So we have a little bit more headroom, but we were cutting it pretty close. But as a bank, we have other scalability issues. You know, every time we deploy something like this, it comes with a control. And in a bank, a control gets tested. We have batches of controls that get tested quarterly. So a lot of engineering time is focused on evaluating those controls. The control tester may not be the same person every time. So you're constantly re-explaining how things work. And you end up investing a lot of time talking about things you're doing in the past when you want to move forward in that continuous improvement to the future. All of this was just driving us crazy. So the number of services times the number of accounts times the number of controls, that is not math you want to do. So let's do a bit of a recap. We now have a cloud governance process with a small army of people, basically threat models each AWS service to figure out how to protect those resources. You know, they are tasked in part to look for scenarios which could breach our service level data perimeters. And we have to periodically reassess those services because Amazon is always moving forward. It's a lot of work with a lot of moving parts. So I know now you probably came to this talk expecting to hear how we conquered the data perimeter with this action-packed story. And you're probably thinking to yourself, it sounds more like a tragic comedy. Well, for the hero part of the story, I'd like to introduce Lauren Betor, my colleague, who's going to tell how we're evolving this into the future.
Awesome. Can everyone still hear? We still with me? All right, I'm in your heads. All right, good morning, everyone. My name is Lauren. I'm a director in Enterprise IAM at Capital One, and I'm really excited to speak with you all today. It'd be good if I went to my next slide. All right, so as Chris mentioned, our current methodology for assessing new services focuses on upfront analysis and research, with the goal of creating controls on a per-service basis. This ballooned into hours and hours of additional time and maintenance and wasting valuable SCP space. And we knew ultimately this wasn't going to be sustainable. So we decided to test some of the data perimeter control objectives that Laura introduced earlier and create a standardized data perimeter that applied to all services. And we hope this would get us out of the time-intensive assessments and result in faster new service enablement. So when we were thinking about our security objectives, we took a look at our cloud governance process and the main risks that it assessed. And we knew that we wanted to focus on credential exfiltration risks. We also needed scalability, as you saw from Chris's slides. That's really important for us. And we wanted to provide a good customer experience. or a good developer experience. In our case, the customer is the internal developers. So we honed in on creating a standardized data perimeter, and if you remember all of those individual policies that Chris was showing before with Lambda and Glue, some were nearly identical in some of their statements. We wanted to replace all of those with a single policy that would, again, apply to all services. On screen is an example of a data perimeter network restriction. Now, when we were thinking about our data perimeter strategy, we had assessed our security objectives, and now we were designing our controls. We knew we wanted a couple things in our data perimeter target state. We wanted to continue utilizing VPC endpoint policies, which would restrict our AWS principals and which resources they were able to access via principal org ID. We also wanted to create service control policies, which would enforce source IP, source VPC, and resource org ID. These would, 1, ensure requests were coming from my trusted principals, and 2, it would restrict my developers from accessing resources outside of my trusted network. There were also a couple additional things that we wanted in our target state data perimeter. And one of them was an SCP that enforced IAM305. For those of you that don't know, IAM305 requires a token to access the metadata service to retrieve credentials. And although that doesn't make token theft impossible, it does raise the bar for an attacker. So we knew that we wanted that in our target state data perimeter. An additional implementation that we wanted to have was within our service control policies, we wanted to have bypass tags for specific statements within the SCPs, and I'll explain more on how we use these or why it was important to us on a later slide. One of the last things we wanted in our target state was actually a key implementation of our existing organization was that we block services such as Lambda and Glue from running outside of a VPC. We would continue these restrictions in our data perimeter SCPs, and this would ensure all calls originated within our network. Now that we knew what we wanted to do, how were we going to do it? So as I mentioned, and I'll keep mentioning, we wanted to focus on security and we wanted to focus on the developer experience. This means we needed speed to delivery for access to new AWS services, and we wanted the services to be in an environment where developers could get a full taste of the service within the Capital One ecosystem. This means we wanted to enable them not in a limited sandbox, but in a true development environment where they could use the services with all of the complications that come with custom company tooling. So we decided to... So our implementation strategy included the creation of a new data perimeter OU, where we would be able to isolate select accounts we were testing and apply the data perimeter concepts at that level. This allowed us to have a separate test bed without compromising the integrity of our 2,000 plus AWS account footprint in our normal OUs. Once we had this in place, we strategically moved accounts over from our normal OUs into our data perimeter OU, usually with a targeted service to enable and test. We chose services that were in high demand by the developer population and didn't have a high number of API exceptions to the AWS global condition keys. So now that we knew what we wanted to do and how we were going to do it, everything went awesome, right? No, we went through so much troubleshooting. We moved accounts into our data perimeter OU, and immediately we were getting access denied errors. If you've worked with SCPs, you definitely know that type of pain. One way we worked through this was through bypass tags, and I mentioned that on one of my previous slides. The policy that I'm showing on the screen is a data governance SCP. which prevents developers from sharing resources using RAM. But you can see in the boxes the bypass tags. So within the SCPs, we added bypass tag availability in individual statements, which enabled us to add these tags to a role and isolate individual parts of our policies to figure out what was actually causing the access denied errors or who the culprit was and giving us any of the trouble. We utilize this bypass tag methodology for many of our troubleshooting situations when we moved accounts over into our data perimeter OU. Yep. All right, on a very fun day of troubleshooting, we had a customer that was getting access denied errors, and we could not figure out what the problem was. Originally, we had thought it might have been related to our enforcement of resource org ID. So we knew there was a code deploy service role that was getting access denied errors, and we utilized our bypass tags to isolate different parts of the statements and SCPs, and through process of elimination, we figured out it might be our network restriction. In parallel, we were also going to CloudTrail to look at event failures, and we saw that the code deploy service role API calls were actually coming from, not from the Capital One network, but from the AWS network, which obviously meant our network restriction was blocking it. In this scenario, what we did is some of the APIs we needed to add them to our SCP exception list, and in those use cases, we implemented mitigating controls. Even with all of the troubleshooting and API exceptions, this was still much easier and faster than developing controls on a per service basis. Okay, now after all of the troubleshooting, then what happened? Well, I'm not sure if Chris, Laura, or I would be speaking with you all today. Well, Laura probably would. But Chris and I, if our testing wasn't effective. So we successfully enabled a number of new services within our data perimeter OU within a matter of weeks, instead of the normal multi-quarter assessment process. Essentially, in our new OU, we flipped the cloud governance model from upfront, time-intensive, customized service-level controls to a standardized data perimeter applied to restrict all services. As we look to the future, we aim to continue rolling this model out to further accounts throughout the year and enable more services within the data perimeter OU. All right, so some other things that I want to mention is the model is really important because we believe it'll result in more real-world data on a service's behavior within the Capital One ecosystem and inform us of the most important or most critical threat vectors. We're sort of open sourcing the cloud governance model, so instead of that small army of people, developers are helping inform us of niche use cases or gaps that there might be. And because of all the data that's going to be created, centralized teams like IAM or cyber will be able to look at the data and easily diagnose complicators or gaps. And then internally, we'll be able to create mitigating controls. And then externally with AWS, we'll be able to hone in on the most important features we need them to prioritize in order to extend data perimeter coverage. We also think that this will lead to a more intentional use of AWS services. And by this, I mean sometimes when a team goes through 3 to 6 months of trying to get a service enabled, they feel a bit married to that service and they're trying to fit a square peg in a round hole. We don't want that to happen, right? We want services to be easily available and accessible to our developers within a restricted environment. And we think that teams will experiment and innovate and eventually lead to using the service that is the best fit for their product use case. and they'll spend their developer time, money, resources on that service instead of whatever ABC service they spent 6 months trying to enable. We have seen a ton of value within the data perimeter concepts and believe it strikes a good balance between security and developer freedom. And because of the confidence we have in the data perimeter, we as a central IAM team feel comfortable handing some of the reins over, only some of them though. We think that devs should be able to get access to new services without anyone in IAM panicking. And with every new use case, we learn something new about the data perimeter and how it interacts with our custom applications or architectures. But we don't want to get ahead of ourselves. We know that this is a journey, and we are excited to continue down this path. So some takeaways and lessons learned, as we definitely didn't have enough time to go into all the obstacles that we faced. The data perimeter is flexible. I know Laura mentioned this on her last slide. So understand your access patterns. The data perimeter doesn't need to be configured in the same way. And in our case, it didn't need to be rolled out in the same way. We used an OU model, but there are plenty of other risk-measured ways that you can roll out the data perimeter and achieve the same results. Another thing I want to mention is enterprise monitoring, because it is a key component of our whole strategy. The enterprise monitoring and compliance platforms that we used in our normal OUs, we continued those in our data perimeter OU. So we constantly had detective monitoring and alerting, just in case there were any random use cases. Anticipate your SCP limits. We have been burned by this many, many times. So at Capital One, we do have a suite of testing for our SCPs. And because of where we placed our SCPs in the tree, it had a higher blast radius than, just applying an SCP at an account level, for example. So make sure that you have a suite of testing, anticipate your limits, especially if you're a company that has a ton of scale. That could be a problem for you and something you need to consider. Expect niche use cases. So there's going to be API exceptions to global condition keys. And in our case, as I mentioned, what we did is we implemented fine-grained access controls as a complement to the data perimeter controls. So your fine-grained access controls and your data perimeter controls are supposed to be used in conjunction with each other. They're complementary. My last bullet is a selfish call to action. So if you are dealing with similar issues where you want to implement the data perimeter, but you're worried about API exceptions or you're missing some global condition keys, reach out to your AWS partners. AWS is a customer-driven roadmap, right? So the more people that we get talking about the same gaps and issues, the better it is for everyone. To wrap up, we have found a ton of value in the data perimeter to provide coarse-grained coverage and restrict in appropriate ways while still enabling developer agility, innovation, and ultimately what this whole speech was about, acceleration to new AWS services. So I want to thank Laura, Ilya, and the Identity Solutions team for their partnership and for the opportunity to speak with everyone today. Enjoy the rest of the conference. Please come up to us if you have any questions, and enjoy. Thank you.